Alrighty, here we go. Let's just run through exam 3 solutions real quick here. The first two are identify what type of bias there might be, what's the most noticeable bias. For each of these, there are several different biases for sure. But inside the box, this new serial short survey can be mailed back for free from the manufacturer. The survey asks the consumer if he or she likes the cereal or not. What will be the most noticeable bias? Well, we're mailing it back. We're voluntarily mailing it back. So this is we're getting volunteers respond. And we know anytime you have volunteers responding, there's going to be some sort of bias there, because what kind of people tend to volunteer? People that feel strongly maybe one way or the other. So we will often get extreme responses. Okay, 2, soft drink company sets up booths in malls that are chosen at random. Employees fill out a survey for the quality of their drinks. While filling out surveys, they are told a properly completed survey will be rewarded with giveaways such as free samples, etc. What will be the most noticeable bias? Well, we usually call something like that response bias. But basically, that's anything that affects the outcome of the survey or the sample, and in this case, they're rewarded with giveaways. So the people that want those giveaways are going to take the surveys. Those that don't want those things, probably not, right? So you're going to get too many people that are doing it solely for the giveaways, and those people are not going to be representative of the population. Okay, does that make sense? And that's what bias is. Bias is really when it doesn't represent the population. Just like volunteers don't represent the population because they're self-choosing. Well, these people are choosing, the people that are choosing are the ones that want the giveaways. So I won't write that down, but that's what we're talking about. Okay, and 3. Management wants to know about the quality of its face-to-face service. For 1 week, they will ask customers directly. Okay, so that's potentially a red flag, right? We're not going to necessarily answer honestly when people are asked directly like that about the post office. After a customer is helped, a different employee asks a customer a short question about her experience. Okay, oh, so this is how they're doing that, I see. So a different person will ask. Oh, so that kind of helps alleviate that. In other words, you're not helping someone and then saying, how are we doing? Or how am I doing? You go to someone else and say, hey, how was your service over there? So that's a little bit better for sure. But there still could be bias in that it's the post office asking. The customers or comments are transcribed by a secretary, so somebody else is writing it down or transcribing it, so there's no bias in recording the results. Survey runs smoothly and a lot of customer comments are collected. What is the most noticeable bias? I think it's a pretty good way to get data. The only thing would be that the fact is that you're still at the post office talking about the person down the way, you know, from the person that's actually interviewing you or asking you questions. So I would say this is probably pretty good. It's probably as good as we're going to get. So no noticeable bias. Although if you did say something to that effect, that they're being asked by the post office about the post office, that I would go with that. Okay, 4. Margin of error. In a survey, 40% said they watched networks news programs. So n equals 7,200. p-hat is 0.40. Find the margin of error for the survey, not 95 confidence. So remember our confidence interval. Okay, this is the margin of error. C star for 95% is 1.96. Square root of 0.4 times 0.6 over 720 calculate what that is, and that ends up being 1.13%, which should be the correct answer. Number 5. A survey of 865 randomly selected voters reveals 408 approve of an issue before the legislature. So 408 out of 865 approve. That's my p hat, right? Construct a 95% confidence interval. Well, again, it's p hat plus or minus c star square root p hat q hat over n. Okay, that's my interval. So if I want to write this out in the 4-step process, we're going to go step 1 prop c interval. 2, I want to check the conditions. We have a random sample. It's given. The second one is np hat, which is 865 times whatever that percent is. Oh, I grabbed a calculator that has no batteries. Times 408 over 865. Those cancel, and it ends up being 408. That's greater than 10. And we do nq hat, which is 865 times the ones that didn't approve out of 865, and that will also be greater than 10, clearly. These are the successes, and these would be the failures out of the 865. Okay, then step 3 goes to our interval, where we've got 408 out of 865 plus or minus 1.96 square root of whatever these values, whatever this is. Let's just do this real quick. 408 divided by 865. So 47%. Let's use this as 0.47. So this would be times 0.47 times 0.53 over 865. And if I do that in my calculator stat test, I'm going to go down to 1 prop c interval. I get 408 out of 865. 95, calculate. 43.8 to 50.5. 43.8% to 50.5, was it? Yeah. Is the interval. And step 4 is your conclusion. I'm 95% confident the true proportion of those who favor the issue is between 43.8 and 50.5%. Okay, 6. Survey of 1,000 television viewers, 40% watch news programs for 90% confidence interval. Margin of error is 2.5. Okay, so here's what we got. We got 40% plus or minus c star square root of 0.4 times 0.6 over 1,000. Right? And they're telling us for 90%, the margin of error is this right here, is 2.5%. Well, if I go up to 95%, what changes about this interval? Just the z star, that gets bigger. It goes from 1.645 to 1.960, and that's going to make this bigger, right? So the interval, the margin of error will be greater than 2.5, so it'll be a wider interval. Okay, and so we know it's going to be a wider interval, and the margin of error, of course, is going to be larger because I'm multiplying by a bigger number here, right? It's going to be C. And that should make sense. If we're going to be more confident, it's going to be a bigger interval. Okay, 7. Interpret this interval. I'm 99% confident that the true proportion of homes sold by an agent is between 70 and 78%. Okay. Great. A state university wants to increase its retention rate of 4% for graduating students. So we know that P is 0.04. That's the retention rate. That's the percent who, after they graduate, come back to grad school. Okay, so we're retaining them from grad school. They implemented several new programs. They reevaluated its retention rate using a sample of 352 students and got P hat is 0.05. So retention rate went up based on this sample, but we want an appropriate hypothesis. The question is, what can we say? Did those new programs work or not? Well, it seems like it went up, but could this have just gone up by chance? Right? We happen to get a sample. The retention rate's still 4%, but my sample happened to be 5. I do another sample, maybe it's 0.03. Right? Okay, so that's why we do a one prop z-test. Okay, and we say H0. I already defined what P is, the retention rate. So we're going to say P is 0.04, and I want to see, do I have evidence that P is greater than 0.04? And here's my sample. Okay, 2 conditions. We have a random sample. It says it was a random sample there, given. And we're going to look at NP is equal to 352 times 0.04, certainly greater than 10. And NQ is 352 times 0.96, is greater than 10. Step 3, some mechanics. I'm actually going to do the test. Oh, here. Let's look at this. This is my P hat distribution. Where we've got mu is 0.04. Right? So we're assuming it's true here. Standard deviation is going to be square root of 0.04 times 0.96 over 352. We want to know, hey, what are the chances that I get a sample of 5% or greater? That's my p-value right there. Okay. Now we find that is do it on the calculator. We're going to do the one prop z-test. 0.04. X. Ooh, I know my sample size is 352. How many in my sample were retained? Well, 5%. So we're going to do 0.05 times 352. I get 17.6, but remember that's a decimal isn't going to fly, so I've got to round it to 18. And I want to know the HA is P is greater than 0.04, so I want to do greater than P0, which is 0.04. And draw that. I get Z is 1.07. My P, oops, I can't write it, is 14.3%. P value is 14.3%. That's this right here, right? So am I likely to get 0.05 just by random chance? Well, I got a 14.3% chance of getting 5 or bigger, so I got no reason to question the initial statement. So 4, since 3 is greater than greater than 5%, since I'm not doing decimals. 5. I don't have evidence that P is greater than 0.04. And I can say P because I defined what it was right up here, right? I don't have evidence that the retention rate has increased. And in terms of this program, or this question, I don't have evidence the new programs worked, or are working, I should say that. Alright, because that's what they're asking about, those guys. Okay, so there's the 4 parts on that guy. Number 9, analysis of a random sample of 250 produces 95% confidence interval for the mean annual salary of this. What can we say? Let's see, well, I'm 95% confident, so I'm going to kind of start looking at these guys. I'm 95% confident that the true mean salary of all nurses is between those values, right? I don't have to look any further. I'm 95% confident the true mean salary is between those values. Not the average nurse salary, but the true mean salary of all of them. Okay? Oh, wait. I'm just looking at a little closer. The true means, I guess those are the same, aren't they? The average nurse salary, the true mean salary. So what's the difference? Oh, this is in Illinois, and this is in the US. So we can only really generalize it to Illinois because it could be different state to state. All right, number 10. Test hypothesis, the mean age of the prison population is less than 26. So we took a random sample of 30, find the mean age of 24. Okay, so this is going to be a t-test because it's for means. A0, mu is 26, and we want to know, do I have evidence that mu is less than 26? Okay, 2 conditions. One, is it a random sample? That was given to us, right? And is equal to 30. And 2, for means, I just need to know that n is greater than or equal to 30. By the central limit theorem, we are good. We know that the sampling distribution, this is the t-curve, is approximately normal. It's mean of 26 and standard error of 9.2 divided by the square root of 30. And we got our sample of 24.4. We're trying to see, remember this is the x-bar distribution. We're trying to see what's the probability of this happening. If the average is 26, how likely is it I get a sample of 30 to be less than or equal to 24.4? 4. And that's my conclusion, so let's do the test. T-test. Stat. Test. T-test. Oops. No stats. U0 is 80. It's going to be 26. X bar is 24.4. Standard deviation of my sample is 9.2. Sample size is 30. I want to know if it's less than. That's less than right there. 26. And we do it. T is negative 0.95. And the p-value is 17.4. So this is likely to happen, right? By chance. So I got no reason to question the 26. since 17.4% is greater than 5%, I do not have evidence that the mean age of prisoners is less than 26, because the sample I got just could have happened by chance. Okay, and number 11. Distribution vacation days offered companies skewed to the right. Okay, so here's vacation days. And we collect data on number of vacation days. We found a sample. We took samples of 60 across the United States. Why is it okay to use the data for a t-test inference even though the population is skewed? Well, what's the conditions to use a t-test? It's these guys, right? Okay. Well, we know it's random, and we know n is bigger than 30, right? Because my sample is 60. But why is that true? Well, if we look at the x-bar distribution, that distribution is approximately normal, right? This distribution here, approximately normal, if n is greater than or equal to 30. That's again by the central limit theorem. But that's why we can do this, because then I can calculate probabilities. I can find out p-values like areas to the right or the left or things like that. Okay. So we can calculate p-values. Okay. I think we are good on that then. There you go.